Hi all, this is Dr. Milshreras from Emmanuel Arasar College of Pharmacy. While presenting the topic called size reduction. Let's move on to the next slide and understand what size reduction is and why it is required. Size reduction refers to the process of breaking down large solid particles into smaller particles using mechanical forces. This operation is essential in pharmacy because it improves dissolution, mixing, stability, and overall formulation. And now that we know the meaning of size reduction, let us look at the main objective behind performing this operation. The first objective is to increase the surface area of the drug particle. This leads to faster dissolution and a better bioavailability. Another major purpose is to increase extraction efficiency for food drugs. Size reduction helps achieve a uniform mixture which is essential for dose uniformity. It improves power stability and enhances power flow properties. It also makes handling and storage much easier. Now let's move on to understand the mechanism involved in size reduction. There are four mechanisms of size reduction: compression, impact, attrition, and cutting. Compression crushes particles by pressure, impact breaks them with a sudden force. Attrition occurs due to friction, and cutting is sharp blades. These mechanisms are affected by certain material properties, which we will discuss in the next slide. Gliding Grinding efficiency depends on properties of the material. Hard substance with more energy to break. Tough material resists fracture. Moisture play an important role. Too much makes the material sticky. Too little make it brittle. Let us continue with the remaining factors on the next slide. Now, softening point substance may melt due to the heat generated during grinding. Impurities affect the consistency of size reduction. The material structure also matters. Crystalline drugs break easily, whereas amorphous drugs are difficult to melt. Now that we know the factors, let us see what the characteristic good reduced particle should have. After size reduction, the particle should have the uniform size, good flow properties, and high surface area. They should not degrade due to heat or friction and must remain stable and uncontaminated. Next, we will discuss the various equipment used for size reduction, starting with the hammer mill. The hammer mill works on impact. It contains rapidly rotating hammers which strikes the material and force it to throw a screen. This mill is suitable for producing coarse to moderately fine particles. Now let's see how the ball mill works. The ball mills operate on impact and adhesion. It has a rotating cylinder filled with balls. As the cylinder rotates, the ball falls on the material and crush it into the fine particles. This mill is used to do fine powders, pigments, and brittle materials. After the ball mill, we have the roller mill. Let's move on to the next slide. The roller mill works by crushing the material between heavy rollers. It is useful for oily and soft material and provide uniform particles with minimum heat direction. Now let's look at the fluid energy or jet mill, which is used for ultra fine powders. The fluid energy mill uses high velocity air jet to achieve ultra fine particles. Particles collide with each other at a high speed and reduce in size. It is excellent for heat sensitive drugs and can produce micron sized particles. Now let's discuss the cutter mill, commonly used for fibrous material. The cutter mill works by cutting the materials using sharp knives. It is the ideal for fibrous substance like wood, bark, and herbal materials. Let us move to the edge runner mill. The edge runner mill employs compression and adhesion. Heavy waves rotate over the material and crush it. This mill is used for preparing paste, ointments, and crushing through tough materials. The next slide covers the end runner mill. The end runner mill is similar to the edge runner mill but uses a rotating pestle and a stationary motor. It is suitable for bed grinding, sticky material, and mixing semi-solid preparation. With the equipment covered, let us now move on to the advantage of size reduction. Size reduction increases surface area, improves dissolution, and enhances drug absorption. It also helps in achieving uniform mixing and better extraction of active ingredients. Now let's look at the disadvantage. Some disadvantages include heat generation, which may degrade trust, dust formation can create hazards, and the contamination from machine part is possible. Also, some equipment like jet mills are expensive. Now let's move on to the application of size production in pharmacy. Size production is important for preparing tablets, capsules, suspension, ointments, and emulsion. It is also widely used in powder, blending, granulation, and extraction process. To understand the theory behind the size reduction, let us now discuss its law. The first law is Kick's law, relate energy requirement to the size reduction ratio. Rittinger's law relates energy to the new surface area created. Bold's law acts as the intermediate law and consider the work index of the material. Let us conclude our presentation. In conclusion, size reduction is a key unit operation in pharmaceutical manufacturing. Selecting the right equipment and controlling processes variables ensure safe, efficient, and high quality drug production. Thank you for your attention.